we're given 3y squared plus 2y plus xy is x cubed. This is a classic example of an implicit function. Y is a function of x, but we can't write this as y equals f of x. We want to find dy dx. If we differentiate right through with respect to x, 3y squared will give us 6y dy dx. Differentiating the 2y just gives 2 dy dx. The xy is a product. Let u be x and let v be y. Du dx then is equal to 1 and dv dx is dy dx. Using the product formula we get v du dx, which is y, and u times dv dx, which is x dy dx. So this is plus y plus x dy dx. And if we differentiate x cubed with respect to x, we just get 3x squared. To write an expression for dy dx, we need to collect all the dy dx terms on one side. Let's take dy dx out as a common factor of these terms. We have a 6y times dy dx, we have a 2 times dy dx, and we have an x times dy dx. The term here is on the other side, and the y was on the same side as the dy dx terms, but we can subtract y from both sides, moving it to the right. To then get dy dx, all we need to do is divide both sides by the contents of the bracket, so we get 3x squared minus y over 6y plus 2 plus x.